This is an example, another problem. It's a problem from the text, and it illustrates something about solving problems involving solutions that we're going to get to in the next within the next couple of chapters. And in this problem, it's important to be very clear what exactly we're referring to when we refer to something like a density. In this problem, there's sulfuric acid, and then there's a solution of sulfuric acid that's called battery acid. And the distinction between the two is very important. I've reworded the problem from what's in the book because, in my opinion, the way the problem is worded in the book could allow you to confuse the stuff called battery acid with sulfuric acid. So here's the way that I word the problem. So automobiles contain battery acid, which I'm going to abbreviate from here on in the problem BA. And the battery acid is 38% sulfuric acid, and it says it's specifically 38% by mass. And then sulfuric acid I'm going to refer to in shorthand as H2SO4. And the reason for that is that we're chemists, and we're going to learn that that's the chemical formula of H2SO4. And the problem is calculate the number of grams of sulfuric acid in 1 gallon of battery acid if the battery acid has a density of 1.28 grams per milliliter. So, what kinds of things are we going to need? So the first thing I do is write down the equivalence relations I need. I see that I have a volume. That's the amount of battery acid I start of 1 gallon. But the density is in grams per milliliter, where volume is expressed in milliliters. So I need an equivalence between gallons and milliliters. All I do is Google gallons, milliliters, and what comes up is that conversion factor. There's other ways you could write it, but 1 gallon is equal to 3,785 milliliters. Okay, next, the other thing I'm given, I have density, 1.28 grams per milliliter. Now, what is this the density of? This is the density of battery acid. Okay, remember the battery acid is a solution, a mixture of sulfuric acid and something else, and that something else is water. So so then I write this, 1.28 grams of battery acid is equivalent to 1 milliliter of battery acid. And here it's very important that I include that as part of the label, battery acid. And then finally, what does this tell me? 38% sulfuric acid. That tells me that for every 100 parts of the battery acid, I have 38 parts of sulfuric acid. Or a way of writing that 38% is that 38 grams of H2SO4, the sulfuric acid, is equivalent to 100 grams of battery acid. Or the correct way of saying this is 38 grams of H2SO4 is contained in 100 grams of battery acid. Now, with these three equivalence relations, I can define conversion factors, and that will simply change the gallons of battery acid into my final unit, which is grams of sulfuric acid. So that's illustrated here. 1 gallon of battery acid. So first I have to, my first conversion is gallons of battery acid to milliliters of battery acid. And I can use this. Notice that this relation applies no matter what it is. This is just an equivalence of volumes, and I can add to that this label battery acid to both sides. After that conversion, I am in milliliters of battery acid. The density, this equivalence relation, allows me to convert milliliters of battery acid into grams of battery acid. And finally, I use that 38% here. It allows me to convert, I put that into here, allowing me to convert grams of battery acid into grams of H2SO4. So in the end, what's left for units is this, and then combining all the other factors gives me the number in front. And the result is 1,840 to 3 significant figures grams of sulfuric acid.